Hello everyone and welcome to another video within the Fusion Zero to Hero series. Today we're going to be looking at additional workspaces. These are the workspaces that are available to us that we aren't going to cover in full, but still worth highlighting from within the interface and really great functionality that extends the abilities within Fusion itself. So the three main areas we're going to be looking at today are going to be assemblies, rendering, and then drawings from within here. So I've started off with a blank part. I've already got an assembly for this created, but just want to go through the process of bringing all of the individual aspects together from within the design itself. So we've been looking at creating an impeller and its housing. We've got a few other smaller components designed as well that we want to be able to add in here. So within a blank design such as this one over here, we've got the ability to simply drag and drop any pre-existing models straight into an assembly and start to assemble them, start to bring them together. But Fusion also supports the top-down modeling approach, whereby we start with a single component, much in the same way as we did with the encasing, and then be able to split that into smaller and smaller components. So you start off with the entirety of your model together, and then break them down into their respective individual components as you begin to add detail to that. In this case, we're going to be using the distributed design process, whereby we take the individual components from elsewhere. So I'm simply going to go and grab from my data panel on the left-hand side over here and drop my assembly file into this. Sorry, I don't want to drag the assembly file in. I want to instead go and grab the encasing and drag and drop that straight in here. So we've got the component in here. You'll see that it is linked to the original model. So whenever the original model updates, so too does this one. We do have the ability at this point in time as well just to go and ground this in position just to make sure that it doesn't move about. So if I go and hit OK on here now, you can see all of the individual components, or all of the components within the assembly itself, the sub-assembly in this case, can move about, which we don't necessarily want. So what we can do very quickly against this component, if I right click, is I can then say that I want this to be grounded or rigid group. So rigid group will ensure that all of the components that sit within an existing assembly only stay true to that assembly, and so they basically come in without the ability to move. So if I go and hit rigid group rather, select all the components I want to create a rigid group of, include any child components, you can see that those cannot move around anymore, which is exactly how I want it for the sake of this one. The only thing I will do is then potentially change the visibility of components from a lower level rather than trying to move them around as we go through. So in that case, I'm going to expand out the encasing and toggle the visibility of the upper case, just so I can start to add some more detail in here and some other components in here, including the current impeller that I have open on the side there. So again, I'm going to drag and drop that straight into this, but this time around, I don't want any rigidity to this. I want this to be able to move around, but I want it to move around in a very specific way. And that specific way is aligned to the central axes of this hole over here, with the central axis of my part itself, so that it can rotate around. To get that going, I can use a joint inside of the assemble panel and apply a joint to the bottom circular reference on here. You'll see any physical reference within the model is available for selection. If it's an edge, I can choose a point along the edge. Otherwise, if it is a circular edge, I could also go and grab a central point. In this case, I've got a circular hole at the bottom of the part, and it will snap directly to the center there. Otherwise, I could use a face, and it will also snap to the center or specific nodes within that face as well. So grabbing that point over there, I'll then go and grab the center of the hole over here at the top, and we can see nice and neatly that fits in within the model itself. So a little bit low, and therefore from the front over here, I might just go and bump this up ever so slightly above, and let it kind of go around up and down like that. This is currently going to go and apply a rigid constraint between the two, or rigid joint, so it's not going to be able to move off. So we want to go and change that to instead a revolute, which will allow revolving, but it will lock it in position in the Y according to the view cube. In this case, I potentially want to just lock this as a cylindrical, which is going to allow sliding along the axes as well as rotation around the same axes. So that way, if I OK that and close this can slide up and down. And the reason I want to do that is we're still going to go in and add the shaft into the inside of the face over here. So dragging and dropping the shaft in, similar process from here. This one's come in with the wrong alignment, which is all good and well. I can use the same process for the joint to then go and grab the top edge of that, considering that the thicker part of the shaft is going to be in the hole itself. So I'm going to go and grab the bottom edge over here and align it to the top edge over here. And provided my my bearing that will eventually be in there, but I don't currently have modeled, provided it stays in the correct position, this should stay then within there. So therefore I only want it to be revolute rather than a slider or cylindrical even. So I've got the ability to rotate this around, even though it doesn't look like much from this angle. We can see it rotating around at the bottom over here. I'll then go and create one final relationship for this assembly between the bottom face of this impeller and the top face of my shaft over there within that little hole. And I'm going to go and create this as a rigid, so that there's no movement between the shaft and the impeller. And that means if I move the shaft, if I can get a good grip on it over there, hopefully gets a good grip on it, we can see that the impeller itself is moving as well, and vice versa. If I move the impeller, the shaft moves, and then the relationship is essentially between the two of them, and then that falls down to the relationship between the shaft and the housing to then determine how these two engage with each other. So we're creating a bit of a linked relationship as we go through. I can then go ahead and toggle the visibility once more of the upper half of the casing, just to make sure that everything does fit nice and neatly inside there. And hopefully, if I've designed this correctly, it does. We've got the ability in the environments then to go and use some of our inspection tools, including the ability to create a section analysis. And I can go and use any face and create a section parallel to that face. And I can go and right the way through this model and begin to see if this has, if the modeling has been done accurately, and if there are any overlaps between our components as we go through. So using that sectional analysis, I can go and establish that actually, yeah, everything fits in here, or most of those. The shaft might be a bit tight on the tolerancing, but the rest of the components fit nice and neatly in there. We do have movement, and there's no other collision between those as we go through. Also within the inspection analysis, we could do a whole lot of other various analyses against the not only the assembly but also the individual components. And a really important one is interference, whereby we can come in and grab two or more items and determine any interference that might be between the two, if there is any overlap between them. In this case, there's no interference because they've been modeled identically. But if there was ever a little bit of an overlap between them for whatever reason, this would be able to go and pick them out directly for us. So this one's nice and good and ready to go for assembly. With those analyses done, I can toggle them off inside of an analysis folder on the side over here and see the assembly as I need to. Another element to this then is the rendering environment. So this is obviously the assembly environment. We've brought all of the individual components together in here. We might also want to then make use of all of the components being together and push out a quick render for our own sanity and for having a look at the component. Also, it looks really good. We can go over from the design workspace to the rendering environment and potentially send these off to marketing or anyone else that might want to have a nice look at some amazing models that we create within our various companies. So I've got the ability to, again, toggle visibility of individual components in here. So in this case, I might go ahead once more and toggle the visibility of the upper half of the encasing and go and grab a view something like this. And with this, I can then start to use various elements to adjust the way this model looks and feels within my environment. So this is taking the materials that I've already applied to the components, but we could go and use our appearance options and go and overwrite any materials that are already inside of this. So I can go into my Fusion library and go and grab anything from concrete and fabric and glass, liquid, metal, mirror, paints for any reason, and drop them in onto individual components, very quickly going and changing their appearances directly from inside here. Once I've got that sorted and I'm happy with the appearances on these ones, I'm going to undo that because I prefer the orange. We've also got the ability to go into the scene settings, whereby we can have backgrounds and lighting environments and all of that we can come in and adjust. So this one's already got an environment in here, which we're making use of, which is just a photo studio in the background. But there are various other environments we can go and grab from within a list. We've got a plaza in here, we've got crossroads, we've got a dry lake bed and a few others. Otherwise, you can also go and attach your own environments in here if you wanted to. So we do have the ability to go and grab HDR or EXR files to add this in very quickly as well. Once we've got that set up, we can then begin to adjust positioning in relation to that environment. If you want the lighting kind of just right and just to the side, we've got the ability to adjust that. We've got the ability to adjust the brightness, change the focal length on the camera if we wanted to. So if we want a really tight close-up or a little bit further out, we've got the ability to have that, changing exposure, changing aspect ratio, and all of those. If we want to make sure that the ground is nice and flat and there's a little bit of a reflection on there, we've got the ability to have that in there as well. So making all of these adjustments, just making sure that we're getting the right output from this. Once we're happy with this, we could then just simply go in and start creating either a in-canvas render or render this out directly from here. So if you wanted to have a quick test to see what this might begin to look like, this will pick up quite a bit of your GPU capacity, but if you go and hit an in-canvas render, you'll start to see some really quick, really nice results on here. You can see based on the fact that this is a plastic part at the bottom over here and metal, getting some real good difference in material and the light scatter as it goes through, including a little bit of reflection on the blades themselves. And this is only within a few iterations. This will then go all the way up to a certain value if you wanted to. Otherwise, we've got this one currently set to excellent. I could drag this to final or infinite, depending on how far I'm willing to push my machine. But yeah, very powerful, very capable. Hopefully it's coming through as nicely on your screen as it is on mine. But yeah, really, really nice textures on here, especially on the plastic on the front over here, to be able to kind of make use of as we go through. Yeah, so that's the rendering environment then. And then the last environment I want to take us through very quickly is the drawing environment. So there's been a lot of work done in the drawing environment over the last few updates. One of them most notably is we've now got automatic drawings available to us from within Fusion. So if I take this drawing or this model and say I want to create a drawing from the design environment, I can come in here and give this a quick save. So I'm just call this one assembly. We can then decide whether we're using a manual drawing or whether we're doing an automatic drawing. If we are using an automatic drawing, we can come in and say, well, which contents do we want to create a drawing of? Do we only want the visible contents? Do we want all contents? Do we want the full assembly in here? In this case, yes, we do. We can then choose the templates. If we've got a template file set up, which standards that template's using, which units of measurements and sheet sizes and the like. And then the sheet creation, because I'm using automatic drawing creation, I can choose at which level I want to create these drawings from. So this is essentially going to go and take, if I go and say at all levels, including external components, this is going to go and take all of the components that sit inside of this assembly. First of all, create an assembly drawing, but then also go and break each of the individual components down automatically for me. So this is going to go and push that through to the cloud to be able to go and generate that for us. I should probably stop the in-canvas render just to help speed up a bit of the process over here, locally at least. But we can see that the generation of that drawing has begun. So this is going to go and create a cloud job for me, which we can identify within the job status over here, just to see how far along that is. But then the other option is just to create a drawing just of a single component or manual drawing, which I'll use just for this impeller to begin with while that kind of does its thing in the background. So same process when creating a manual drawing. If we go into the design drop-down, drawing from design, we can then say instead manual. We want to go and manually go in and add some detailing to this. Again, we got the ability to choose which contents we include, which components in here, which drawing, whether it's from a standard or from a template file, and a few other variations in here, whether we're using landscape, portrait, whether sheet size is a fully customized one or preset size, and so on. But once we've got that set, we just hit OK there. This will then go ahead and create that drawing sheet for us, where we've got the ability to then go and place views down for this component. So I can go and choose my alignment to it. At the moment, this is looking at the front. I want to go and look at the top of it and place this down as a base view. I might even want a 1:1.5 scale on this one, just to make that a little bit larger. Any tangent edges, whether we want to show or hide them, or how we want to show them from within here. And then we've got the ability to go and place this down. I seem to have lost that as it was creating that other drawing in the background. So I'm just going to reposition this one once more. So top and 1.5. And place it somewhere over there. Once I'm happy with that setup, I can hit OK on there. And this is going to go and think about that for a few seconds and then place that view down for me. So you can see you've got all of those tangent edges are using the hidden line or dashed line line type, just to indicate them nice and neatly on there. If I double click on the view, I can edit how this is all shown and change the style. So only visible edges, visible with hidden edges. I can also show shaded, or shaded with hidden edges as well. So we've got variations in the way we can view this as well. Quite like the shaded on this particular one, so I'm just going to hit OK on there and keep shaded in there. I can also go ahead and create projected views. So I'm going to take that view and project it to the top, get a side view of the part. I've also got the ability to create an isometric projected view. If I decide to go with that option, I might go and do that from the projected view over here, just to get a nice isometric view. Something like that should be good. And then each of these views can be repositioned as we go through. So isometric views, they can move around anywhere on screen. The original views will, or the orthographic views will want to keep in line with each other, as you would expect. Make sure that we've got the detailing in between the two of them there. We can also create sectional views. So if we wanted to section a particular part, go right down. I'm not going completely down the middle on that one. Let me try it again. Create a sectional view right down the middle of this one over here. And place that sectional view off to the side. Where we've got the ability to change the hatching if we wanted to. We can change the color of the hatching if we so desired. And a few other variations, scale, angle, and like. We've also got the ability to then, as you would expect, dimension these drawings. So we've got the ability to use our dimension tool. We can go and grab the diameter and go and grab the height of the component. I can go and grab edge lengths if I wanted to. I can go and grab between there and there, and get an edge length of that particular component, and a few other values that we might want to, including the internal diameter, the external of the shaft, and then the overall diameter of the part itself, which we already have at the so it should be okay. So those are various options that are available to us. If we are using this for further detailing, if we've got holes in here, especially standard holes, we can go and grab the parameters around those holes and place them in here, and they're looking at particular features for that. I'll go and move back quickly to the assembly drawing that's taken place in the background, just to show that off a little bit more as well. So if I go and open this assembly drawing here that was just created in the background, we can see this is using the automatic drawing functionality. So with the assembly, it's automatically gone and ballooned the individual components that sit inside of this assembly for us and given us the table in the top right. If we do decide at any point in time to go and change any of that information inside of our dimensions panel, we have the auto dimension options, which we can go in and make adjustments to. But as I said, it's going to go ahead and create drawings for each of the individual components. So it's gone ahead and created base drawings for my my impeller, sorry, not my impeller, the encasing, and we can see the individual elements inside of that. So this is still the assembly. And then it's gone with the impeller with all of the dimensions that may be required against this impeller itself. We can then decide whether we want to use baseline dimensions, chain dimensions, symmetric dimensions, symmetric with baseline, and a few other variations, as well as then the density of those. So if we decide that actually this is too many or too few dimensions, we can come in and increase or decrease the density of those. You can see it has picked up 35 in this view that it could go in and add, but it defaulted to about 10, 15 or so. So we've got the ability to use the slider to increase or decrease the number of dimensions that are currently inside of this. If I OK this now, this drawing can be adjusted any further, so I can fine tune exactly how I want this. This isn't here to just replace us, but it's just to go and speed up the process. We don't want to go in and add so many dimensions all the time. It would be nice if a software came along and added those dimensions in for us, and we could tweak them as and where they need tweaking, which is exactly what Fusion is doing at this point in time. So again, I can come in here and bump up the size of the views. I can change the scaling of the views, and once that's done, you can see the dimensions stay true to where they were. I can move these views around. I can remove dimensions. I can still come in and add dimensions in along the way. So we've got a lot of flexibility still available to us from within here. And again, this is for each individual component. So here's the shaft. We'll then have the encasing itself once more, and then a few different views of the encasing, quite handy, as well as then the top plate. So it's picked up that the original assembly of the encasing itself had multiple components to it, and it's now breaking them down nice and neatly for us just to get a good view of all of the different surfaces involved in that particular model. The last little bit of really handy functionality that they've added fairly recently within Fusion's drawing environment are the document settings. They've really expanded the options that we have available to us in here. So we've got the ability to fine-tune exactly how we want our drawings to work. So we've got the standards that it uses, the unit of measurement, the projection angle, and the like that we can come in and read from here. But we've also got the ability to apply settings to the font in terms of height and family. We've got annotations. We can choose the color and styles of the annotations down to the views, and each individual line inside of a view, whether it be the outer lines, tangent lines, hidden lines, we can come in and change exactly how each of those are set. And better than that, even further, I guess, we've got the ability to import settings in as well. So if you do have a template file and you've got files that already pre-exist, we can basically take that template file and push those settings into any new or pre-existing files as we go through. So really handy to be able to import those in as well. But you can see here, in terms of some of the automatic drawing functionality, we've got a whole lot of settings we can come in and apply against these as well. So I really hope that helps expand your understanding of Fusion, and once you've kind of tested this and seen how nice and easy this works, that it then helps to encourage your use of the different environments in any step of the process. Whether it be taking a few quick visualizations in the rendering environment, whether it be taking your individual components and pulling them together, or whether it be pushing out drawings for manufacture later on down the line. So yeah, this video has gone a little bit longer than I was initially expecting it to, but hopefully that's got enough detail in there for you. And other than that, I will see you all in the next one. Thank you very much for your time. Bye for now.